Hi, I'm going to explain the basic operating system called Pintos. We are going to use Pintos as a toy operating system, and we use all the project on this Pintos operating system. Pintos is an educational operating system. It is very small. It has about 10,000 lines, and basic forms of Pintos is barely empty. And it is very easy to use and easy to understand. It is good if you can read the Linux source code, but Linux source code is very large. It consists of 1 million lines. Moreover, 80% of 1 million lines of Linux code are for device driver, and it depends upon the hardware. And you will not need all this device driver code to understand the basic components of the operating system. And it takes about an hour to compile a Linux, versus Pintos is simple and takes about a few seconds to compile and run a program. There are many ways to run a Pintos. You have your notebook or PC, and you will have your own operating system as Windows, Mac, or Linux. To do homeworks, you have to run Pintos on your operating system. To do that, you have to install a virtualization machine so that your computer, your operating system provides a bare hardware on top of your operating system. So there is a number of software that emulates hardware. QEMU is widely used virtual machine, and there is Bulk, and there is VMware. You can use all this virtualization hardware to run Pintos. I'm assuming that you are ready to install QEMU, and I will start this example from installing QEMU. So please pay attention to my window terminal here. Let me just clear things up. And from now on, first I'll have to install QEMU in my machine. The first thing is, in case of Linux, you have to run sudo application get install QEMU. This is the command to install QEMU on your machine. In my machine, I'm using a Mac, so I will use Homebrew to install QEMU. Okay, so I have already installed QEMU on my machine. It takes about a few minutes, so I will let you install QEMU on your own machine. After installing QEMU on your machine, you will have to link the QEMU binary to the standard directory file. So you perform sudo link, and then link the i386 QEMU version to the bin file. Oops. Okay, now the Pintos compressed Pintos tarbor is uncompressed into all the subdirectories. Let's go to the Pintos. Okay. So we have a nice source directory here that contains all the source files. I'm using Mac, so I'm using Darwin. So I have to modify some of the files before I am getting this Pintos working on the compilation. Let me do that. To compile Pintos, we have to go to the threads directory. So let's go to threads and compile it. Okay, so it says that there is something wrong. The reason we have failed is the compiler has failed to select the right compiler option. So there are a few changes we need to make. First one is change the emulator to QEMU. So and change this one with QEMU. Then there is another important thing you have to change. So we have to change the compiler options. Go to the source, go to source/make config. And then from 20 to 34, we have to make the Pintos running upon this compiler. So we have to comment everything else out. like this. Oops. Okay, so everything's set now. Then it's time to run pintos. Pintos minus dash dash run alarm multiple. Pintos has been created correctly, but the path hasn't been set up. So you have to set up either you have to set up the path, or you have to specify the precise location of the pintos when you run the program in the command parent directory and parent directory and their util then pintos. The reason is that the pintos by default using the box simulator. We are compiled pintos based upon QEMU simulator. To run our pintos correctly, we have to specify that we're going to use QEMU as a simulator. We failed to find where the QEMU is. At the last step, you have to make the QEMU available in the shell script, and you have to specify the path properly. To do that, we're going to create a sublink user local bean / QEMU system i36 to QEMU. Okay. Now let's see if the QEMU is available. Good. So now let's run the pintos again. Let's pray for the best. Pintos is not in the path, so we have to specify the location of pintos. Voila. So we have successfully executed pintos. Here, if you specify a -q option, then pintos finishes, pintos machine quits QEMU after it is done with executing the alarm. So we're gonna give an option to alarms, different runtime options, alarm single. And then after alarm single is called, it powering off. In the normal situation, pintos should quit with when you supply -q option, and the machine needs to be ready to accept the next command. But we have observed that pintos does not quit properly. The reason is that there is something wrong with the ACPI module. In that case, you have to add out W options in the shutdown.c file. Okay, let's go to the device file, device directory, and let's look at the shutdown. Okay, here, this is a special command that tells the pintos and QEMU to quit. We are going to add proper statement. We are going to modify the line properly. Here, we're gonna add a line to set the register 0x604 and 0x0 or 0x2000. Okay. And then we are going to build the pintos again. Okay, now pintos has been constructed properly. We're going to run the pintos and see if the pintos quits correctly. So first, specify QEMU as hardware and tells the system that you should quit after run and alarm single. Okay, it started and it quits. So now that's the end.